Hi friends, this is Ajay. Today I am going to show you how to design a piston head using CATIA V5. Okay, just enter into the part design, name the part, that is piston head. Okay, enter into the sketch workbench by selecting front plane. Simply draw a rectangular here. Okay, like this. Specify the width of the rectangle bottom line, that is width of the rectangular, that is 92 by 2, because the 92 is the diameter of the piston head, so I am going to give the radius of the piston head, that is 46, and the height of the piston head is 67 mm. That's nice. Okay, afterwards select the corner point of this rectangular and origin point, make it into a cone side. Okay, now trim the top line of the rectangular, select the arc by 3 point, draw an arc. Okay, make the arc center coincide with the vertical line. Okay, afterwards double click on this one, select the end point of this vertical line and or make it coincide. Same here, select the arc and end point of that line and make it coincide. Okay, afterwards specify the dimension of an arc, that is 189 mm. That's it. Okay, afterwards trim the unwanted lines, this one and this one. Okay, exit from the sketch workbench. Now use the shop option, then select the axis of rotation, that is the Z axis, make it revolve. Okay, here we created a solid form of a piston head. Now we have to design for a grooves over the piston head. Okay, grooves for the piston ring. For that, select the front plane, enter into the sketch workbench, use chevelette option. Okay, chevelette edges. By using this we can extract the edge lines of the cylinder like this. Okay, select these edge lines and make it into the constructive mode. Okay, now create a rectangular and specify the dimensions. This rectangular, after revolving it, it is used as a grooves over the piston head. Okay, for that here we have to give the dimension according to, it is the depth of the groove, that is taken as width of the rectangular, that depth is 4 mm. For that I am giving a symmetry, so that it is taken as 8 mm of the width, and the thickness of the groove is taken as height of the rectangular, that is 3 mm. Okay, now zoom in, right plan. Okay, select these two, just select these two lines and allow symmetry to with this constructive line. Okay, next select this top point of the constructive line and this line, give the vertical distance between the top surface of the piston head to the grooves surface. Okay, that is 2 mm, like this. Okay, now exit from the sketch workbench. Before using the chevelette option, we have to call a body. Okay, after that you have to use a boolean operation, so it is necessary to call a body 2 is up here. Okay, cut the sketch and paste into the body 2. Okay, the sketch is appear into body 2. Okay, now use the chevelette option. The axis of revolve is Z axis. Okay, like this we created exactly like as an piston ring. Okay, but we directly can't use this is as a piston ring, so we have to assemble those piston rings. So we main intention here is we are going to design for grooves over the piston head. Okay, goes for piston ring, and select the again select this shafted part. Okay, use pattern, number of instances and spacing. The number of instances is 5 and spacing is 5 mm. Okay, then reference element is z-axis. Okay, in the exact direction as we require. Okay, now here we created again few more ring like structures. Okay, after that use the boolean operation to remove this part. Okay, like this. Okay, we created grooves over the piston end. Okay, then again we have to use another a groove over the bottom of the piston head, at the bottom surface of the piston. So for that, again enter into the sketch workbench, selecting the front plane, and simply draw a rectangular and specify the dimensions of the rectangular, that is the width of the rectangular as well as 8 mm, and the height of the rectangular is 2 mm. This is little bit different from the above grooves. Okay, for that we have to call for again another one body. Okay, so again use this silhouette option, select the cylinder, make it into constructive mode, select and zoom in, select these two lines, allow symmetry with this constructive line. Okay, then specify the distance between top surface of the groove and bottom of the, just select this end point of the constructive line and top surface of the rectangular surface of the line. Okay, that is the distance is around 7 mm. Okay, here we specify. Okay, after that exit from the sketch workbench, use insert option, call a body. Okay, cut the sketch, paste into the body 3. Don't need to necessarily every time you have to cut and paste. You directly initially you starting during entry, before you entering into the sketch workbench, you have to call the body. After that, enter into the sketch workbench. Okay, now use the shaft option. Okay, select the axis of reference line, that is z-axis. Okay, here we created another one ring like structure. Okay, use the boolean operation. This body has to be removed from the pod body. Okay, like this. Again, bottom ring groove is generated. Okay, like this. See. Okay, now we have to design for a hollow inside the piston head. Okay, for that again insert a body, select the bottom surface of the piston head, enter into the sketch workbench. Okay, just draw a circle here. Okay, and specify the dimension as we required. The internal diameter of the piston head, hollow piston head, is 74 mm. Okay, coincide with the center point of the circle with the origin. Okay, now exit from the sketch workbench. Here we pad it in reverse direction up to the distance of 62 mm, that is 62 mm. Okay, now use boolean operation, remove body from the piston head. Like this we can create a piston head over piston head. Okay, after that we have to Again we have to design for that internal supporting for connecting rod, internal supporters. Okay, for that we have to use reference plane here. Before using that reference plane, insert a body, collar body. Okay, select front plane and reference plane at a distance of 25 mm in reverse direction. Okay, just like this. Okay, here we created one reference plane. Okay, on that reference plane, select that reference plane, enter into the sketch workbench, fit into the fit. Okay, just select a circle. Okay, create a circle of diameter is as given in the sketch is 40 mm diameter. Okay, make constraint over the vertical axis of the center point of the circle, coincide. Okay, cue the vertical distance from the bottom or horizontal axis of the workbench, that is the vertical distance is as given in 27 mm like this. Okay, then exit from the sketch workbench here. Okay, just pad the generated sketch in reverse direction, but here give type of the up to the surface, the type of pad in up to surface. The limit is given as this surface. Okay, just press OK like this. Okay, we created internal cylinder, that is inside the hollow cylinder, inside the hollow surface of the piston end. Okay, after that select that padded cylinder. Okay, make it mirror using mirror option with the center axis. Okay, here we generate two like this, two supporting cylinders inside the piston head. Then afterwards simply generate okay, we have to add this body using boolean operation, add or assemble to the pod body. Okay, afterwards we have to create a hole over the piston head using hole option. The hole type is counter bore. Here we have to select on this. Okay, let's see. Here we have to create a reference plane over the surface of the cylinder head, piston head, using offset from the plane, or okay, by using offset from the plane we can generate or else here by using parallel through points, two lines through the tangent to the surface. Use it tangent to the surface, select the tangent surface. Okay, the point is here and drag it and drag this. Simply we can use here offset from the surface plane. Okay, by giving a dimension of offset about as we taken as diameter, half of the diameter, that is 92 by then the plane is created over the surface, okay, surface of the piston head. Now select that plane, enter into the sketch workbench. Instead of entering into, just use a hole option, okay, hole over the surface, okay, enter into sketch workbench. Constrain this whole center point with the vertical axis. And give the vertical distance about 27 mm. Okay, now exit from the sketch workbench.